Good afternoon, ladies and gentlemen. My name is Howard Weinberg. I'm the managing member of Emergence Technology Consultants, and I'd like to discuss with you matters near and dear to my heart, which is linear LED replacement lamps for traditional T8 fluorescent lamps. Next slide. Emergence, just very quickly, is the largest single provider of this technology to the U.S. hospital sector. We started in 2008, and to date we have 40,000 lamps installed, literally with zero failures, which we're very proud of. More importantly, we are not resellers or distributors of often inferior products that we've all seen from Asia. We have developed production capabilities whereby we literally control all the subcomponents and selection and acquisition of all the factors that go into the building of our product, literally from the acquisition of the diode and its subcomponents to the final product. Next slide. LEDs are everywhere. We represent to you very clearly that this is not an emerging technology. The common LED, or light-emitting diode, was first developed in 1920 and then commercialized in 1968 by General Electric Corporation. And as we look around, they're really everywhere. They're in our automobile headlights, all of the little red lights that you see in your taillights of your vehicles. Now we see them on traffic signals, street lights. There's about 130 streetlight projects around the United States ongoing, displays, signage, the side of the bus, the side of the trucks, and such. Times Square, as an example, are all very good examples of a very, very mature technology. Next slide. And as you see from this photograph very quickly, we can go to the next slide, they come in a variety of forms. The interesting part about it, however, is that when we look at this slide here, as an example, with these various types of these PAR 30s and screw-in or Edison-type LED products that are now very commercially available, and we see them in a linear form looking like a fluorescent replacement lamp, we often don't distinguish the fact that down to the molecule, this light here, or these lights that you see in this format, are really identical to that which we've been able to refine in a linear form. Next slide. Today, innovation has developed a very slim circuit board that has rows and rows of diodes placed in the same direction, mounted on a heat sink. They're affixed to bipins and to the same traditional lens as fluorescence. So in its simplest form, this allows far brighter and really better quality light to be deployed at documentable lower wattages than our current fluorescent technology. And actually, in actuality, our product and many products out there besides ours are coming in now at about 50% less energy consumption. That is, a standard 4-foot 32-watt fluorescent light bulb now can be replaced with an LED product giving out the same actual light at the work plane for about 16 to 18 watts of energy. Tremendous savings to the end user, and certainly a benefit to all who are trying to reduce the consumption on the grid itself. Next slide. We feel that really it's not an emerging technology. We'd like to call it a truly disruptive technology. And in fact, that we don't believe there's any other single technology out there that can have such a dramatic and immediate effect in reducing both energy consumption and greenhouse effects other than getting rid of these traditional fluorescent lights. They are not one lamp fits all. They are very costly still because of the cost of the diode production itself. Essentially, in the end, though, they are very cost effective, and the simple payback to end users in 24/7 environments. And that would be a hospital as an example that we focus on, or a factory or a manufacturing facility where the hallways, stairwells, and certain areas really never turn the lights off. In those environments, 24/7 environments, they're very cost effective, often with the payback or the return on investment to the end user in less than 2.5 years, provided that they receive some sort of incentive or rebates from the local utility companies, which many offer. Next slide. Just really quickly, on our statistics of the 40,000 lamps or so that we have out in the marketplace, as you can see, we've been able to reduce on a yearly basis for those end users about 5.5 million kilowatts per hour of electricity, which equals, as you see, about 3,700 metric tons of CO2. And in a truly financial environment, that equates to $1.2 million worth of electricity costs that are now reduced to about 632,000. Again, an empirical 50% reduction. This calculation is made at an average rate of about 11 cents per kilowatt hour. Next slide. And the benefits, we believe, are almost endless. There is nothing out there that reduces power more or quicker. They have very long life expectancies if manufactured correctly, often over 50,000 hours, which is 5.7 years. Reduced replacement costs, better quality light. They're very environmentally friendly. They contain no mercury or harmful vapors. And in fact, one of the things we don't have time really to discuss very much today is the fact that mercury poisoning or the discharge of mercury in our landfills is a very serious problem in the United States we just don't often hear about. The California Department of Toxic Substances Control has often called this the fluorescent light bulbs, a toxic time bomb. We believe that as the world advances and these become more mainstay, we're going to see a dramatic reduction in that mercury poisoning in our landfills as well. The other point is that because there is no flicker, it's a consistent and high-quality light produced by an LED. Many problems associated with fluorescence that we have heard about in the past, headaches, eye fatigue, and such, and generally your biological clock, if you're working night shifts and such, can be greatly either removed or improved by, again, the advocation of this type of technology over its current fluorescent light bulbs. Next slide. So the real question then is, as we go through life and try to evaluate this for our end users, and particularly utility companies that want to be able to offer these rebates, who do we really turn to for guidance? Next slide. The Department of Energy has been at the forefront of the research and development in these kind of activities for many years. The DOE, however, really does what's stated on this slide right here. They form alliances with engineers and builders. They support the deployment of demonstration projects. They do a lot of good work in providing funds for researchers. Next slide. But in the end of the day, and one other point, within the Department of Energy, they have the Building Technologies Program, which has really now come a long way in finally advocating that LEDs are very well suited to a variety of lighting applications. They are very competitive, as I just stated before, in 24/7 environments. But again, it is buyer beware because of some of the poor quality products that have first entered the marketplace in the last 2 or 3 years prior to today. Next slide. What we often don't understand, however, is the DOE is not the authoritative source for the use or application of any of this technology in the United States. They're not empowered as an accreditation agency for the solid-state lighting technology industry, nor do they really determine the technical qualifications for any lighting products. The companies here on the right are really our authoritative sources in the United States. If you go to the next slide very quickly, and then you'll see such as NEMA, ANSI, the Underwriters Laboratory. These are all the technical resources that we can turn to for highly qualified information on what we need to look for in the industry. Next slide. And of course, the universally recognized source for all of us is the Illuminating Engineering Society of North America, the IES. They have actually developed the testing protocols and the baseline by which we all test our products and compare apples with apples with regard to the performance characteristics of any linear or other LED technology out there. Their one publication in particular is called LM7908, which is the kind of Bible, if you will, for the baseline testing of products side by side for lumen output, color, and the associated qualities that we need to look for when we actually go out into the marketplace and look at a linear LED replacement lamp. Next slide. And often the other interesting and really good source for us is called the Lighting Handbook by IES. This really establishes lumen efficacy at the work plane. And if we go to the next slide, I believe we will be able to, yes, what we do initially as we go into the world and as an end user comes to us, we need to always understand that the primary objective of any lighting project is to satisfy that end user's requirements. In the end, it's the consumer's choice, not anyone else's choice, as to what kind of light they need in their facility, what levels of light, what color of light. And often, many spaces are tremendously overlit because in the past, lighting designers and engineers haven't thought through or did not have to think through the inordinate cost now that we all bear with regard to energy or electricity costs as we try to light our facilities. So in spaces where the existing light levels are appropriate, we can maintain them with an improved technology. However, to put it another way, maintaining those acceptable levels while using half the electricity is really the only way we're going to achieve some real true energy savings in the world. Next slide. And as we try to explain to everybody, really it's not lumens that we look at when we can try to compare a fluorescent light bulb with a linear LED light. It's really foot candles or foot candles at the workspace or at the work plane. And as we also try to educate everyone, when you have a traditional T8 bulb that's rated at 2,800 lumens, and we now see an LED replacement lamp come in at 15 or 16 or 1,700 lumens, we often mistakenly think that that means we're getting less light at the work plane. When in fact, if you look at the diagram on the right, you will understand that a great deal of light, almost 30% or more according to the Department of Energy, is often lost in the fixture because of the 360-degree circumference, if you will, or diameter of the bulb itself and how it disperses light within the fixture, which has to be redirected down. At the end of the day, that 2,800 lumen traditional fluorescent light bulb can only be producing as little as 1,680 lumens. So therefore, really what we need to look for is not a side-by-side or apple-to-apple comparison of the lumen output of the light bulb itself, but actually, again, how many foot candles do we need, how many foot candles are acceptable, or minimally acceptable at the work plane in order to be able to do a true evaluation of the two technologies side by side. Next slide. And again, this just continues to go on from what I just said. The apples-to-apples comparison is trying to look at the light distribution in foot candles at the work plane. Remembering, foot candles are a measurement of light intensity, how bright the illumination is of an object when the light hits a particular object. It's a measurement that's taken at a single point. So it's very easy with a very simple light meter to place one on your desk. As an example, take a foot candle reading of what the light is or what you need the light to be at your desk level with a fluorescent bulb, then have it tested or demonstrated with a linear fluorescent light bulb, where you'll find that in many cases the LED replacement lamp will give you better quality light and actually more foot candles than what you would think you're receiving from the fluorescent. Next slide. But this also has a lot of challenges. And as you see, I list some of the challenges we have here. Every environment has different characteristics. Every walls are different, floors are different, they reflect light differently. We have different kinds of lifetimes we have to compare. A traditional fluorescent light bulb is stated to last 20 to 24,000 hours, and LED is stated to last, let's say, 50,000 hours or 5.7 years. All of these challenges, the quality of illumination, the cost effectiveness, all really come down to the diode itself and how it's manufactured and powered. If we can focus in the future on evaluating and asking the right questions of the vendor with regard to how his diodes are actually being manufactured and what they are producing, we can then get a metric and a baseline that will allow us to feel assured that, in fact, in the end of the day, we're getting a high-quality product that really is going to match our needs and provide us the energy savings over the 50,000 hours that are represented by the manufacturer that the product should last for us. Next slide.
Howard, to allow for questions, how much more do you have?
That's it. We can. Well, the presentation itself is available to everybody in the future. Correct?
Oh yeah.
Yeah. So we can stop right there if you want, and go on to some questions. This is just a very quick picture of the two major types of diodes that are available on the marketplace, and I can kind of close right here by saying that, as you notice, each element of these, the construction of each of the elements within each of these products is really where its performance and long-term use really come into play. And again, if we can focus on asking the right questions we can then be assured that we'll have a high-quality product that will last us.
Okay, thank you. We have a question here from Randy Wong from PG&E.
So this is a DC product, is that correct?
DC product, correct.
Yeah. So
we use an external power adapter.
Okay, so
Many people out there have tried to take the AC/DC power adapter and place it inside the tube. We don't advocate that, nor does the Department of Energy right now. It creates heat within the tube and also has some other more serious problems related to possible energization of the fixture itself, when you have to reroute the building wire, like 120 or 277 AC voltage, directly to the tombstones to power the tube through its bipins. We've advocated a much safer approach. We use an external power adapter. It looks, think of it as a ballast. You simply remove the current ballast. You put in our ballast or our power adapter to the building power. And then we just extend two wires, which are just 650 milliamps at 23 volts out the other side of the adapter and connect to a male-female coupler that is wired to the back of the tube itself. So our bipins are simply there to hold the lamp in place, avoiding any UL issues or any fire hazards associated with older tombstones that may not be rated to take constant 277 24/7, a much safer solution, we believe. And also, we generate no heat within the tube itself, so therefore the diode package itself is pretty well protected and unaffected by any external heat.
So the question is, does it affect the UL listing of the fixture once you take out the...
No, it does not. There is really no way of affecting the UL. UL is not really it's more of a time stamp for the fixture at the time that it's placed in. When it does not actually, even with the internal ballast bulbs, it don't actually affect the UL. UL has come out with some guidance now as to how you have to readdress or relabel the fixture in order to be able to identify that it has been changed and therefore prevent any shock or any hazard of someone coming in and putting a fluorescent bulb in a year later and having it explode in their face and such. But it does not affect the UL itself. We have ULs on both our fixture, the light itself independently, as well as our power adapter. I can't speak for others, but I know it doesn't affect the UL per se of the fixture, but it does have to be UL compliant by reaffixing statements to the fixture, as I understand it, in order to caution those that the fixture itself has been changed out since its original manufactured date.
And what's the cost per fixture for this, for a typical two-lamp fixture?
Well, the cost runs generally in the marketplace for a 4-foot linear LED replacement lamp we see between $50 and $55. We've seen them as high as $110. Our cost is between $65 and $70. And while that feels like sticker shock in a way, we have to remember that that's really not a valuable way of looking at the comparison. You can't compare a $2 or a $5 fluorescent lamp to a $65 or $70 LED unless you take into account total cost of ownership. Total cost of ownership is how many lamps are we going to have to replace over the same time period, but more importantly, what is the cost of electricity and how much are we saving? If you compared my lamp as an example, or one lamp of many that we designed and deploy, against a standard Sylvania or Philips 32-watt Echo, I think it's called, or Octo Echo lamp that costs $2, that lamp itself, probably over the same 5.7 years of operation, cost about $140 to $150 to operate with replacement costs and such, where ours over the same time period is about $100. So it is very cost effective if you run very simple numbers against a 28-watt more high output bulb that is stated to last 36,000 hours, as an example, with standard fluorescent on high output 28-watt, which are a little more expensive, about $5 or $6 per lamp. They cost over a 5.7-year period about $180 to operate, again, where our lamp would be about $100. So the total cost of ownership is very important to understand when you look at the prices. Prices can be a little, as I just stated, a little deceiving. The sticker shock is really not really there when you look, again, at the total cost of ownership over time.
So the cost that you quoted would be including the adapter?
That is correct.
Okay.
For our product, we quote $65 for the through pin, $70 for our surface-mounted unit. We have one just came out last month called Healthy Light. It's the first near full spectrum LED package on the marketplace, particularly made for hospitals. Better quality light, more daylight looking light, if you will, to alleviate all the problems associated with better patient care, better patient health, better worker employee health, particularly when they're working on night shifts and such. But again, the product itself is packaged where the adapter and the lamp itself all is inclusive in one price.
Okay. All right, Howard, we're out of time. Appreciate your answering all the questions and participating remotely.
Thank you.
We'll be posting the presentation for everybody else to see the rest of it at our ETCC website.